Welcome back everyone. In this tutorial we will pick up where we left off from the intro video. What we done there was we made our main curve, and on that main curve we made 11 sections, which equals to 100 sections, which equals to 101 planes. In this part of the tutorial we will continue on to create the beams, these beams, and hopefully we'll have time to also make the major helix. So with that out of the way, let's get started. Before we engage back to the I-beams, something has what I like to do is actually I'm using this 3D mouse, and as you can see, the moving around is also quite okay, but when the geometry itself gets further away from the origin, weird things can happen. And the same goes for moving around. So what I want to do is I want to move this as close to the origin as I can. So what we can do is we apply the fix between this and this, because everything we're going to be using the main curve goes from this point from that point onward. So we have to apply the fix somewhere here. What we can do is we take the middle point of our curve. Let me draw what we want to do in theory. Let's take a middle point, or any point, doesn't matter, and translate that back to the origin. And with these 2 points selected, we can have a vector. And with a vector is we can simply use that vector and move this whole bunch back to the origin. So that's theory, and let's put that to the test. In order to get the center point of a curve, what you can do, you can use point on curve, this one. But I'm not really a fan of using this one. What I always use is actually curve evaluation, which actually does the same thing, except you have a bit more control. So the C is obviously the curve, and the T is the parameter on which you want to have that point. This is what we want. These two are, I think, the tangent, or the vector, and the angle. Okay, we will not be using that. So this is our curve. Now, in order to get the middle of the whatever curve input you have, there are 2 ways you can do this. One is, if you know the length of your curve, then you can just simply enter the number here that is divided by 2. So the length divided by 2 will give you the center point, and that will be your parameter. The easier way would be to right click here, reparameterize your curve. What that will do is whatever length this initial curve is, in our case it's going to be 280. So the domain of that curve is going to be 0 to 280. Without the reparameterization, the middle point would be 280 divided by 2, which will give you 140. If you put in 140 here without reparameterization, you will get the middle point. Actually, let me show you. And this will always be the middle point. But because we know the length of this curve, it's easier for us to find that. But let's say for some reason our curve is slightly longer, for whatever reason, or whatever reason we don't want to know the length of the curve, or the length of the curve is it's not an integer, it's like a fractional number with decimals. In that sense, what you can do is always reparameterize your curve. That way it makes the domain of the curve from whatever it is to 0 to 1. Always. That's what reparameterize does. And the middle of 0 to 1 is 0.5. So that makes it easier for you to quickly grab the middle point of any curve regardless of their length. Now that we have the middle point, what we can do is we can create a vector, 2 points, that goes from here, and remember we have an origin point there, so we're going to use that. Lastly will be move the actual geometry using the newly vector we've created. We're going to be using that geometry, And as you can see in the highlight here, it's already moved. So we just need to plug that back in there, and we have moved our curve, which should be easier for us to select and a bit more easier to control also. Back to the frames that we created. One thing we can do is we can start creating the circle that is going to be defining the major helices. So circle, it can catch a point or a frame. Let me hide this one. And we need the radius, so we can actually grab this. This is actually diameter, so we need to divide this by 2 in order to get the radius. And we can right click on the R, use expression x divided by 2, x being the input, and now we should have 5.4. Okay. Now that we have the circle, what we can do is we can start dividing the circle based on the number of tubes that we have. And remember, the outer helix has 6 tubes. So we need a number here. I'm not sure if I want to add the number here. Actually, let's do that. Let's add 6. And then we can call this number outer helix. Actually, okay, there we go. So you just copy that away. Number of outer helix. So what we're gonna do is we're gonna have to divide our circles with that number. Okay. I'm actually noticing something that is going to be troublesome. If you look at the photo, let me get a good photo for you. Perhaps this one should work. Now this is a photo from looking underneath the bridge. Okay. And if you notice, we talked about if I want to draw a section of our helix, and this being our deck, these 2 points is where these helix will always cross, meaning we'll have about, I think, 3, something like this. Now 1 is at the bottom. The problem is this tube is always at the bottom, and what we have here is the points. There is not a single point that is always at the bottom. Well, you don't really have a point that is actually at the bottom, let me say. So if this is where, oh, that's not a good drawing. What I'm trying to say is that the deck is not that high. The deck is actually somewhere here, right? But the way that our circle is now divided, the seam doesn't allow us to have 2 points here and 1 point at the bottom. So what we're gonna do, I have to rotate all these to the right direction. And one way we can do that is to move the seam of this circle. So let's just do that. We just type in move seam. These are the ones that we want to, actually, no, we don't want to move seam. We want to rotate it. Let's rotate objects. This is the object we want to rotate, and we want to rotate them based on these frames, based on these planes. And we're gonna have to redefine that. Oh, without doing anything, it seems like we have to write uh, half a pi. I think that's 90 degrees. Oh, I'm not I'm not a fan of radians, so what I usually do is just put it in degrees. And I think let me create a slider 50. So this is the original situation. What we want is we want to have one point at the most bottom. And let me see. Seems like something like 35 could do. But 35 is such a weird number though. Or 90 actually, that makes more sense. But okay, wait, let's have a look at where that point is actually. Let's evaluate the curve that it's not being rotated. We will reparameterize it and then we say, what does it look like at the start? Okay, so without rotating the curve, the start point is on one of the sides and it rotates that way. Okay, okay. So we need to rotate one quadrant basically, and that, so it starts here. We need to rotate it either that way or this way, which translates to 90 degrees. That's easy enough. So this is 90, so it should be, let's delete that and let's just put it in here because we don't need that slider. Now with that fixed, what we also have is a good position for our deck using this point. So that's what we're gonna do. Oh, let's take this on. Okay. One way to select those points in order to draw a deck is we can just use the list item, and let's just turn that back on. And then just select the ones that we want using a number slider. But this is a lot of handwork, and I don't like being having to come back here and adjust this myself in order to get the right one. Because if the tree structure of this changes for whatever reason, or if we were to, for example, let me show you. So in index 0, or let's say in index 2, is one of the points that we would like to grab in order to draw the deck, the I-beams, right? But if this were minus 90, where would that go? Suddenly, it's on a different position. And we don't want to come back here and adjust that every time something changes in the front, which mess up our tree structure. So what we're going to do, we're going to build something that is able to accommodate all that, regardless of whatever changes that come through. And one way we can do is we can actually, say, I want a point or plane somewhere on this level. I want you to calculate the distance between all these points to that plane, right? And only give me the points that is closest. In that way, it doesn't matter where the points are or whatever index they are, because if we employ this method, then we are basically skipping all those indices of order and just pick the ones that's logical, basically closest to the plane that we will define. If you're not understanding that yet, that's fine. uh, I'll show you right now how we're going to do that. So we need to define that plane first. We know that the center of our circle is actually somewhere above the planes that we're going to be using. Let me actually leave a drawing there so we can actually see it a lot better. So if this is our circle, the center point will be somewhere there, and we want to move it down somewhere here. One way we can do that is, I believe we can use this one instead, because we know the diameter is that, and it looks to me that we can actually move it down by, was it 1/4? Let's try that. So let's see, let's do a subdivision. Actually, no, just division. That one divided by, let's try 4 for now, which gave us a number 2.7. If I were to move something down there, let me see. Let's grab something from here. Let's grab, I don't need all of it, I just need one item. I don't need all the items. So I'm gonna grab one of these, which is a frame. I don't know what that frame is. Oh, that frame is at the bottom. Oh, no. Oh, okay. Now I screwed up my, but it doesn't matter. We know what we want to do. Oh, wait. Well, that means that the beginning is now at the end there. Not sure how I feel about that. If this were the right orientation and this is the Marina Bay Sands, this is the start. We don't want it to begin here. Actually, we want it to be here. So what we're gonna do is we're gonna apply another small fix to the beginning of our curve. It's a small fix, so we're just gonna flip the curve. That's all we're gonna do. Just flip the curve. And what that will do is suddenly this beginning is here, which is exactly what we want. Actually, I can maybe make a point XY point construct. It's called the new ones, and we can actually say, is that no? That's not. Then that's not a good way to do it. We have to do it with this. We have to do whatever geometry is already built, so that they can always go along with it. In the event that this main curve is not sitting on this z direction, but somewhere much higher, then that will mean that the number here will not make sense anymore. So we have to use this one instead. Okay. Let's see. What we can do is we have that. We can move it down already using on the z-axis. This one goes here, and what that will give us, oh, we need to move it down, so let's apply a negative number anywhere there, doesn't matter where. Let me see. If I look at the side, oh, it crosses those points exactly. Okay, that's cool. We don't need that point. We actually want a XYZ point plane, because that's how we're gonna be comparing all our points. All right, and now we can say point closest to plane, I believe is what it's called. Point plane closest point, exactly. So S is the sample of points that we're going to be testing. That's going to go there, and the plane is obviously this one. So if we were to plug in a distance on this, which is the D, we can see what the distances are. Basically, we have a distance 2.7, which I'm betting is this one. Another one that's 0.00000, that's almost 0. I think it's either this or that one, which is same as this one and this one. And these two are probably there, and 8.1 is probably the one on top. So we have the distances. What we can do is we can sort our points based on those distances. So we can use sort, and k takes a number, and A can take any point that is corresponding to the same number. One problem with the sorting actually is when you sort a number, negative is always going to be at the bottom, right? As you can see here. So what I expect here is in the end, after this sorted list, I can show you. You'll see that the minus 2.7 stays at the top because it's a minus negative number, so it's always the lowest, and then followed by one of these two, and then the rest. One simple way to solve this is to actually apply absolute number for the distances, because we just want the distances. It doesn't matter whether they're negative or positive. That only tells you where they belong in relation to the plane, but that's not important to us. So we're going to absolute this, which will render every number a positive number. And now if we were to sort this, we will have the two small number at the top. And in that way, what we can do is we can do a list item on index 0. It's always going to be either this one or that one, right? So we can actually do this plus 1. And now we can use line to create all the lines that we need for our curve. And then the next part is let's create the beams actually. Since we have a line, we can create a beam from it. What I suggest is, let me draw this out. Because we have this beam, right? What we can do is we draw, let's say, a profile like that and extrude it that way. The length of the of all these lines, which should be 9 meters, I believe, if all goes right. 9.3. Okay. So that's close to the numbers that we got from the information that we gathered previously. Yes, so let's create a profile first. We're going to start with a rectangle. So a rectangle needs a plane, x, y, z, and the fillet radius. So we need planes in order to create a rectangle. So what we can do is we can do perpendicular frames on all of our lines, and we're going to reparameterize it so that we can say 0 or 1 is going to be always at one of the ends. So we're going to do 0. I don't know which end will be. Apparently it's going to be that end. And we're going to apply our rectangle. Our rectangle doesn't have to be, what is this, 2 meters by 4 meters because of the domain, minus 2 to 2. So we're going to create our own domain. Let's say construct domain. Okay. Actually, we need to define the beams. Let's create one because I don't think we'll be changing this very often. Let's have a look at the pictures. So if I look at this picture, right, and if I cut this through here, what I imagine I will see is probably something like that. Whereas the distance here is, I don't know, 200 millimeters, 150 millimeters. So let's stick to that. And then this, we can either give it 300. We can always change that later. It doesn't really matter that much for now, but we just want the geometry there in order to give us a better visualization of it. So let's do that. Or better yet, we can give the height of the beam the diameter of the tubes. That way we have one less number to edit ourselves, but that's up to you. Anyway, so as I mentioned, 0.15 because we're working with meters. We're working with millimeters. So it has to be 150. Actually, it might be better to work in meters, because if we, this is quite a large, all our numbers is actually based on meters, so we need to change this, the units, to meters. Absolute tolerance, I might want to increase one more. Now that it's changed, this will have to go back to 0.15. So let's call this width IB. And this gives us domain of 0 to 15. So that's a total of 300 millimeters width. Oh. Ah, something wrong there. Oh, right, of course. 0 to 15, 0 to 15 equals nothing. So one of these has to be a minus x. There we go. But I think that could be a bit too wide. I'm not sure. A 300 width beam. Is that correct? Let's have a look at if I can find a photo that shows this a bit better. Perhaps this one. I don't want to say that this is 300 millimeters while the radius of that is only 273. So this looks more like probably 150. So we're gonna do 150. We're gonna divide it even more. You can divide it here, or we can actually do it here, and we say x divided by 2, and here also x divided by 2, the positive side. This should give us a total width of 15. So with that out of the way, let's do the other one. We can call this height. Oh. Height of the IB. We talked about having it 300, so we're just gonna do that, and it should be 0 to 15 to negative 0 to 15 to 15, 0 to 15. So this is what we have. The zooming is still a problem here, so what we're gonna do is I'm just going to use one item and zoom back in that one. Okay. The next one what we can do is we can just boundary surface this part. Ooh, 50-60% of our script already, and extrude the direction it should extrude. Actually, we can say extrude along curve. Maybe that will help. Extrude along curve. The poly surface to extrude, which is this one. Actually, that one. Because we just need to insert profile, and the lines are these. And then what we can do, because this is a bit lighter to use, what we can do is, these are still open poly surfaces, and we can just cap it open BREP. Once we capped it, it becomes closed BREP. Closed BREP is always preferred if you can, so that's why we're using this step instead. We might have to move this down. I'm not sure, to be honest. We might have to move this down because this is the center line, and I imagine that we're going to be drawing our deck right above that line, which will intersect with our beam. So we have to move our beam half of its height down in order to make sure it doesn't intersect with anything. So let's do that now. Well, actually, let's do that here. We can actually correct that here. We can say it's the height is 0, and Actually, I think if it has to go down, I'm doing it wrong. If it has to go down, it should be a minus number going up to, so we can say the number here is 0. There we go. That fixes it. So we don't need to move anything. We just need to adjust that one. Okay. Uh, let's put on a preview so we don't have to look at these red geometries all the time, and we can start using a render mode to show us something that was like way better stuff. This is the render mode, and we can add in a color and make it a bit more, give it a bit more life basically. Something like that should work. So there we have it. We've created our I-beam. Okay, that took way longer than I expected to just make the I-beams, but I hope you've learned something new regarding the components that we used, especially the distancing and the logic that is employed in order to select, or in order to always select what we want the script to select, instead of using a lot of list item with manual control on the indices. So I'm gonna stop this here. In the next we're gonna tackle the outer helices. But if there's something you don't understand, or something you want to ask, please do. And with that, I'll see you in the next one.